Okay. Okay, so hello again for everyone who are joining using WebEx. Oh, I haven't turned on my video. Okay, so yeah,
Fine.
so that you can see my face and how I'm
Yeah.
actually looking at. Okay, so let me repeat again. So for next week, no class, basic math, calculus, and we might have a makeup class, okay, for both basic math and calculus. Or maybe just basic math, okay? Or maybe just basic math. It depends on our progress this week. So I will announce later if we confirm to have a makeup class on this Saturday. If not, then maybe the next Saturday. Okay, so not this Saturday, maybe next Saturday. So my plan for today's class is actually reviewing some parts on what we have, okay, especially for exponent and logarithm. Some practice. I think more likely to have like more practice today. So it takes maybe until around 1.5 hour or maybe less. Okay, if we are progressing really quick. And yeah, I hope you guys can check the previous video that I upload and share through the Moodle. So today is 10th class. So you need to check the ninth class, the 9 again. Okay. Uh, so this is actually what I uh, I have done in that video. So hopefully you guys have watched or maybe just skimming through all the sections on the video is okay. So it starts from exponent, just a few notes how to get into the curve, okay, and how to transform the functions, and as essentially later we are going to see how we can solve some algebra through this exponent. Okay, so this is, and again, this will be the definition of the Euler number, the E, and I give you some other video as a reference so that you can see how actually this number really means, okay? How the exponential growth is really attached to our nature, okay? How we can grow from one, like you count the populations for any living beings, animals, maybe a human, how the populations like behave when they increase. Okay, so it's not like from one point to another point, like there is like jump. So there is something there which can be described in the Euler number. Okay, and you can watch those videos. So exponent, and then we move on to the logarithm, which is the inverse of the exponent. As you may see from the graph here, it's the definition by graph through the y equal x, which is um, showing that the exponent is the inverse of the logarithm. Okay, and then some some transformation. Okay, some transform, how to transform the functions, how to shift the functions upwards, and how to mirror. Okay, and also how um, to get the property in logarithm, some simple property that is um, essentials, and also for the natural logarithm, basically the same. The difference is the natural logarithm is log with the base of e. Okay, and then we get into the law. Okay, then this will be very important, especially if you want to solve some algebra that requires the logarithm. Okay, so we are going to practice more of this, okay, later on. And then some proof I mentioned here, and you can review in the video that I mentioned initially. And I also mentioned how to evaluate some expression through the law of logarithm, and how to combine the expressions and solving the algebra to solve finding the number x, okay, like this one. And maybe this is just combining the expression. And notice that warning, I give you warning here. Sometimes students make this mistake, so be careful on this logarithm. Okay, do not make this mistake. Okay. So another thing is the change of base. Okay, so we can do this. Okay, we can do this with any log with any base. Okay, so you can add, for example, from this definition, you can add log with any base. So I will write log with base a. So we can write this, and basically we can have this as our property to change the base, basically. Okay, to change the base. Okay. So this is the change of base formula. So within this formula, we can write that the log base of b of a is equal to 1 over log base a of b. Okay. So this is quite interesting. Okay, you can do this, and then you can manipulate your algebra. Okay. So because I believe algebra will be necessary not only for calculus but also for your other engineering related courses, as long as you are able to solve the algebra parts. Okay, you are actually like solving 1/3 or maybe half of the whole equations. Okay, so especially if you want to deal with formulations in engineering, maybe in like if you are eager to learn mechanical engineering, you need some, especially for robotic and robotic arms, the translation, the rotation movement, they are all described within the linear algebra, which requires sophisticated algebra solver, usually using matrices or just using some system of linear equations that requires some algebra skills that you need for that. So I think very, very essential. Okay? So that is the log. And then solve the equation itself. I mentioned some of the expression here, how to solve and how to find the x. Okay. Sometimes you are allowed to find the x in terms of the decimals as using calculator. But I think to help you to practice, um, if you write and then just write as like this one, this should be okay. It should be okay. Don't no need to worry on how to make it into simplified. Okay, if you just end up to here, this is okay. Okay, this is an answer for me. Okay, so here's another one here. Okay, and this another one here. So you are expected to be able to solve this. Okay, so we have this course now, solving the log. Next class, I will move to another section of the chapter, so not the exponent and log. So it means the next class, so the 2 class after this, it was expected to have another quiz. Okay, another quiz related to this polynomial. So quiz after 2 class, polynomial and exponent and log. Okay, and then after that, we learn trigonometry. That will be, I think, one of the last part. Okay, if we have another time, we are going to have system of linear equation. Okay, so that will be the last sections. Okay. So this will be another quiz, but after 2 class. Okay, after 2 class. So yeah, another examples here, and yeah, I will move to another slide here. Let me move here. Okay, let me go through. So I hope you are ready with some paper or your iPad in beside you. So we are going to see how much we learned from the exponent and log. Okay, try. The first thing is basically we refer back to domain of the function. Okay, So try this one, okay? Do not wait for me to solve for you, but you need to try to check the domain of the function, okay? Okay, only two questions here. You can start the first one, the function of f, and the second one, function of g. Okay, anyone solve number one, the first one? What is the domain of the function? Okay, how about Kai? Number one, what is the domain? Anyone who finished? How about Jason? Jason, are you there?
What?
Yeah, how about the domain of the first one? Have you tried?
X greater than 1 over 2? I'm not sure if it's correct.
1/2 is correct, but not completely quite correct. Okay, not quite correct. So I think I will just give you this one, the first one here. Okay, so the 10 of power with power of x squared, this is supposed to be a positive component, right? So everything can be input. Every x can be input there, so no worry. The one that should be worried is this one, right? So let me write here. So remember, I said at the beginning of the courses that when we deal with the domain, I give you the shortcut. There are only three cases that you need to be careful. Okay? If you have rational function, right? And then if you have the with this roots, and then you have the log. Only this, okay, that you need to be take care of. Okay? There are no other way to complicate the domain. Okay? So only these three and their combinations. For example, we can combine this together here, like that, or the log can be combined like that, and it's all possible. Okay, to combine all the testing, or maybe 1 over log, and then that. And we can combine also. Okay? But that's not the important thing here. Important thing is when we have those combination, we know how to solve it. Okay, so we have log 1 minus 2x. Log, remember, can log be 0? No, right? So we need to make this greater than 0, which requires that. Now, every time we need to multiply with negative, the whole system of this inequality need to be changed like that. So we have this. Okay. So we have this 1/2, or maybe because this is only one number, so I think we can just conclude that domain is from, okay. Okay, how about number two, function g? Number two should be the same, with the same reason with number one. We have log, right? And then you need to solve the quadratic, right? Anyone want to solve this? What is the answer? What is the domain?
All real numbers.
Yeah,
All real numbers.
all the numbers. You
Yeah,
mean
all real numbers.
all the
Minus
numbers?
infinity and don't.
Okay, all the numbers. If you put 5, what's happened? 2 plus 5 is 7. 7 minus 25 is minus. Can log be minus? Can log be minus?
I don't know.
Hmm? Cannot, right? So again, this is the same principle as the first one. So every component inside the log, it needs to be greater than 0. Even it cannot be equal to 0. It cannot be equal to 0. Okay? It needs to be greater than 0. Okay? It cannot be negative. It cannot be 0. Okay? So here we have, so greater than 0, or if this is y, okay, need to be greater than 0. Okay? Y is just to denote the inside of the integration. Oh, wait. I gave you the wrong equation. So I know, okay, Alfonso, you are correct. So it can be every x. Okay, correct. For this one, it can be every x. Okay. I give you the wrong wrong equation. Sorry. So domain is for all, right? Okay, correct. But if let me, I give this, it means that we need to solve this equation. Okay, and we want to make the highest quadratic here as positive, so we multiply with negative, so we have that. Okay. Or I think don't worry about this inequality, because as long as we know the endpoints of the interval, or the roots of this, okay, this will be, you can write this factor, right? So let me move that. So we have -1 and 2. We can check, okay, how should be done. So we check 0. 0 is negative, and this will be positive. Oh, wait. Negative, yeah, negative, negative, positive. And 3 will be positive. Okay. If we follow this one, then we are going to have this. If you factor out this one, I think should be the same, but with different roots, right? Different roots. But for our case here, that this will be the domain. Okay. Okay. That is if the question is this. Okay. So I have a typo here, actually. Okay. For if this is all 2 plus x squared, this becomes like all real number. Okay. Apply, can be applied. Okay. Any question first? I think okay, right? We can follow. No big deal for domain, right? Okay. Okay. Now next one. Let me go here. Okay. How about this? Okay, we start from the first one. Solve the equation. We have a exponential equation. 2 with power of 3x minus 5 equals 7. Okay, you can try first, at least maybe two number 1, number 2. And after a couple of minutes, I will solve that. I don't think you need to write in a decimal, so you can end and simplify as long as you are able to. But if you want to find using decimals with calculator, I think for now it's okay. But if this happen in exam, I think you can write in terms of log or write in terms of fractions. Still, it's okay. Okay. So, but the basic idea, whenever you see any exponent and your unknown x is on the part of power as a power component on that exponent, what you should do is to make sure that component going down. How to make that happen? We are adding log. Okay. So we are going to change the expression, the exponent, by adding the log. But how do we add log? Okay. I think, okay, in calculus, we usually add the ln, right? because ln is basically log with base of e, which if you remember in calculus, we are able to differentiate or derive easily the ln. But now we can think with the other log with variety of bases that we can choose on. Okay. So how do we choose the base? Okay. How do we choose the base? So basically, so if we have, let's say this is 2, we can say that this one is basically, if we add, oh wait, if we add log in front of this, and then log, if we add just log, it means the log is in base 10. So there is a hidden number 10 here. Okay. But I don't want 10. I will look for another number. I will choose the base equal to. I would choose 2. Do you know why? Because if we choose 2, I can remove the power, go here, right? So I will write 3x minus 5. And this is perfectly log 2, base of 2, which is equal to 1. So it's pretty convenient, right? And then we have log base of 2, 7. So this will be gone because it's equal to 1. Or you could think using the basic definition of log. Okay? So whenever you have a with power of b equals c, right? The definition of log is basically this will be the base, right? So log base of a, right, of c is equal b. Log is equaling to the power, right? So basically, we are saying that based on the question, oh, okay. Based on the question is actually log base of 2 of 3x minus 5. Oh, wait, of 7, sorry, of 7 is equal to 3x minus 5, which basically the same thing when we add here. So either you are using the left part or the right part, I mean this one here. Basically, they are resulting the same conclusion. So you could take your minds from this part, adding log left and log on right side, and then you can just simplify, okay? Or using the basic definition of log itself from the exponent to log, and you get that same result, okay? So basically, you can just finish off by taking the 3x, and then 5 will be there. You could try to find like the log. If you want to use calculator, you can try to find using the change of base like that. Okay, so you can compute this through calculator if you want. Okay? But if you stop here, still okay for me. All right. Okay, I think I need to duplicate this. So I will, each page will be each number. Okay. Is it clear? If you feel something unclear, you can let me know, and maybe I will stop for a while and then explain a little bit what what does that mean? Okay.
Mr. Man, I have a question.
Yes.
How did you get log 7 over log 2?
Yeah, that is basically the change of base rules. Okay. I think it is based on here. Let me go back here. Here. So this a is can be any base. Okay. And I choose the log base 10 to make it easy to calculate in calculator if you want to calculate in calculator. Okay. So that is change of base formula. Okay. I've put all inside the last video, in the last video, the last week video. Okay, I will go back to this. Okay.
Thank you.
Okay, good question. Okay, I will move to the next number. Okay, so I will delete this one. Okay, we still have this. I just duplicate. Okay. So number two is this. Okay, so x squared with e power 2x, 2x, e power 2x, and 8 e power 2x. How do we solve this? This will be very simple, actually. Anyone solve this? Number two? And number two? Anyone would like to try? How about Dang? Dang, are you there? Or just keep online and I cannot see you? How about Fabrizio? Fabrizio, are you there, Fabrizio? Fabrizio? Okay, I think the soul is still not there right, yet. How about Ben? Ben, are you there, Ben?
Hello?
Yeah. How about number
Uh,
two? What do you
not
think
sure
about number
actually.
two?
I was thinking just use LN, but I don't know where to go with the
Yeah.
LN8E.
Okay, okay,
So
okay. Okay, okay, okay. So I believe for number two, this is for everyone who are confused how to solve this. Looking at this number, the equation, we have all the e. Right? So how about we are moving to the one side and then we factor out the Alphonsus, do you want to ask something?
Can I try?
Hmm?
Can I try?
Yeah, do you want to ask, or maybe
Can
you
I
have?
try?
Huh? Yes.
Can I try with the question?
Yeah, yeah, yeah.
So I think we can uh because every uh, number like everything here has e to the power of 2x, so maybe we can
Mm-hmm,
group them into like e to the power of 2x, like and then inside the bracket is like x squared to x and like 8,
mm-hmm, mm-hmm.
and
And then
then from there
you solve that, right?
and then like e to the power of 2x equals to 0, and like the one inside the bracket equals to 0.
Mm-hmm, mm-hmm. Yeah, yeah. Correct, correct. Yeah. According to Alphonsus, we can write this as, let me use, so we can write e to the x. Okay. So this will be x squared plus 2x. And then the 8, we move to the left, become minus, right? So minus 8. And this will be equal to 0, okay? And then we see that the e to the x will not, impossible to be 0, right? Because it's a positive function. Every number that we put inside the exponent, it always be at least positive value, right? It cannot be 0. So we only care about this. And basically, this is a simple quadratic equation which we can factorize easily, okay? So we can factorize. This will be that, right? So x is -4 and x is 2, okay? And that's the answer, okay? Just -4 or x equal 2, okay? Okay. And then we have the other two questions is log. Log. Okay, Dang, you want to ask?
So, okay.
Yeah.
Oh, no. I
Yeah.
want to solve like the next one. Oh, is it okay?
Yeah.
Like, so like using the product rule, we like rewrite it to like log x
Mm-hmm.
times x plus 1
Mm-hmm.
equals log 12. And then
Mm-hmm.
like we set the expressions inside equal to each other
Mm-hmm.
and just solve. And we got like x equals -4, x equals
Mm-hmm.
3. Is that
Mm-hmm.
correct?
X -4 or 3. Okay. The X is okay, but we need to check
Mm.
after we get that. We need to check again. Okay. You
Oh,
are
okay.
correct after that, but we need to check. Okay. So Dang is a correct method. So let me explain here. What should we do to check? Okay. So actually, what Dang say is we take the product rule for the log, right? So that is the way. So we have x squared plus x equal 12 or x squared plus x minus 12 equals 0. So from here, we get, and then from here, we get that x is -4 and x equal 3. Now, if we look at each of this expression, for example, if we take the x equal -4, if we check here, log -4, it's not possible, right? Because it's not in the domain of log, all right? So the only possible way to see is just the x equal 3. So this is the only answer, okay? So this is not in domain, okay? So when we put x equal 3 on these two, so these two expression, it's satisfied, right? It's satisfied. And if you see that it's +1, so 4, 3 is equal 12, right? Okay. I hope that helped. Okay, that helps. Okay. So again, domain is very important. So every time you solve the equation, don't forget to check. Don't forget to check each x. Okay. So if you have like quadratic functions at the end or quadratic equations, you will have like 2 x's. Or if you have 3, will be having 3x. Okay. So that is the number 3. Okay. Let's start number 4. I will duplicate again, and I will erase this part. Okay. Okay, so I think later I will like this whole exercise here for every phase. I can make a note especially for the in the Moodle. Okay, I will put in the Moodle. Let's try number 4. So I think this will be the same, right? This will be the same. So I think we can take the expression, we combine all together, right? But then you need to be careful on the right side of the equation. 1, we have 1. Anyone would like to try? Down, you want to try again? Okay, if you want.
Yeah. So
Mhm.
it's the same as before, and then we got like 8 to the power of 1 equals x plus 5 times x minus 2. And then it became like 8 equals x squared plus 3x minus 10.
Mm-hmm.
Right? And then it's like x squared plus 3x minus 18 equals 0. Then we factorize. We got like x equal minus 6 or x equals 3. Is that correct?
Okay, I think let me just process what you've done. So I think pretty similar, right? Let me write this. Let me write here. So log with basis of 8. So you multiply this, right? And 1 will be log 8 of 8, right? So log 8, this will be x squared plus 5x minus 2x is 3x minus 10. And this will be 10, right? As you mentioned, right? This will be 3x minus 10 minus 18. Yeah, I think you're correct. Okay. I actually haven't tried this one, but according to your numbers, should be correct. So this will be plus 6 minus 3. Right? I think we're correct. And then, how about if we check this too? Will it be okay? I think if we check the negative 6 here, negative 6 here, a problem, right? A problem. So I think this is cannot, right? So the only way we can take the answer is this on the x equal 3. Okay. So similar to the previous one, every time we finish and then it seems like we find the x, we need to check again. We check again whether it is on the domain or not. Okay. 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 Now I have a few more practices, at least 2 or 3, or maybe 2 pages, maybe, or 3, 2 or 3. We can see later if we maybe need more. Then okay, we can continue. Okay. All right. The next one. How about this? Read the question first and carefully answering the question. So you have a P and Q. That will be the key. And this is also becoming like, I think, do you get this kind of question in your high school or not? I'm just checking because I think I did. I did in my high school. I get this kind of question. So you have like some definition, and then you are express another expression of log. Yeah, Ben, you get this, right? So you need to express those new expression of log using the previous definition that is given in the information. For example, in our case, we have P and Q, and do not like it has the log with base of A, right? It can be any base, like even like with number or with just random bases should be okay, because we don't really care much about that as long as we can we can reflect or we can correlate what the question is to the definition. Okay, which means can we relate the questions into P or Q or combination of both of them, right? So express each of the following in terms of P and Q, and then the final answer may not contain any logarithm. So that is the clue. So we need to make sure that the final conclusion for both of this question should be in terms of P and Q only. Okay, we need to remove the logarithm part. Okay, how to start this? How to start? Well, we can start now. The first one, the log base of A 100. What is that in terms of P and Q? Okay, Ben?
So you can find 100 in terms of 4 and 5s.
Mm-hmm.
What I did is it would be log A 5 times 5 times 4, or like 5 squared times 4.
Yeah,
But I
554.
separated
Yeah.
it so that you can make it product rule, and it
Mm-hmm.
becomes log A5 plus log A5 plus log
Mm-hmm.
A4, and then it becomes 2Q plus P.
Oh yeah, good, good. So we can start by looking this number. Okay, we can start by taking this 100, and we can think like what is 100 made of? Okay, what is composition that can, if we multiply the numbers, it will result in 100 from this 4 and 5. Okay, so 4 and 5 it's become 20. 20 to become 100 it needs more 5. So 5, 5, and 4, or 25 with 4. So we can say like we can write this as log 25 and 4, and then we can see that we can make the 25 5 squared like that, and we can make like 4 like that, right? And then we can write this as, and this will be basically 2Q plus P, as Ben said. Okay, I hope that's very clear. So the same thing with the second one. We have 0.4. So 0.4, we can write this as a fraction for with divide by 10. So 4 divided by 10, if we simplify, is this 2 over 5. Okay. So let's start from there. So log base of a, 2 over 5. Okay. This will be, we can use a subtraction to express the division. So we have log base of a of 2 minus log base of a of 5. Now, in the definitions, there is no log base of a of 2, right? But it is quite related to 4, right? Because 2 with power of 2 is 4. So we could say that if we have log with base a of 4, to make it into 2, we need to have half, or the root of 4, right? The root of 4. So this can be how log base of a 4 plus or minus, sorry, minus log base a 5, or half p minus q, and that's the answer. Okay. Any questions? So remember, in the logarithm, we can power with a fractions, right? So basically, we are taking the roots. We got taking the roots. It can be square roots. We can take the cubic roots. Okay. Okay. Maybe if you are maybe if you didn't come from the early classes today, I'm announcing that next Monday, no class, but we might have a makeup class on this Saturday. Okay, it's still not confirmed yet. I will confirm within this week. Hopefully tomorrow or Wednesday I will confirm. Okay, and the next 2 classes after 2 class. So today and then 1 more class, and the next one will be quiz. Okay, quiz will be consisted of polynomial and exponent and log. Okay, like 2 chapters. Okay, so polynomial and the exponent and log. And that is for the quiz.
Sorry for interrupting, but what is the quiz?
Quiz is, let me write here. Quiz, polynomial, and exponent and log. Okay. So this is supposed to be after the class, after the next class. Okay. We are not sure yet when. Okay, so I will announce later. At least 1 more class. Okay, exercise and giving you introduction to trigonometry, and then the next one will be the quiz. Okay.
Alright, thank you.
Okay. Okay, let's go to the next one. Okay, we have this now. Now slowly it will getting more and more a little bit still okay, but we're going to see like slowly we'll be having more and more advanced. Okay. Okay. Anyone want to try? Okay, Ben.
Is it okay if I do it again? So this one, you just make it product rule again. Well, it's
Uh,
actually like the subtraction
yeah.
becomes
Mm-hmm.
like division, right?
Mm-hmm.
And then you can make the two go up for the
Mm-hmm.
log a, so it
Mm-hmm.
becomes like log a 3 to the power of 2, and
Mm-hmm.
then you can cancel all the logs, and it becomes x squared minus 10 over x equals to 3 square.
Mm-hmm.
And then you just solve it like normal, and you'll get x equal 10 and x equal -1, but then you don't accept -1.
Oh, right. Okay. 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 Good. That's correct. Oh, wait. I just read the message from Fabrizio and Alvaro. Oh, sorry. I just read. I didn't. Okay. 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 If you think the is too fast, let me know. Okay. Okay. So this one, we take the log base of a, and then because of this minus, we can do this, right? And then we can make like that, right? So basically, we can get equal 9. Okay. Since the domain of log, okay, let me write here. So since domain is always positive, right? So I think it's okay if we solve this by taking the multiplications and we solve it, become 9x like that. So x squared plus minus equals 0. So x is minus 9 and y minus 9 minus 10, sorry, and then plus 1, right? Yeah, and x is 10 and x is -1, and of course we try to check. So if we put -1 here, it's become impossible, right? So the only way is just this x equal 10, the only answer that can satisfy the equations, right? I think if you want to quickly write the notes, if you are using either using laptop or using your phone, you can take a screenshot, okay, and then so you have like, no, this is just my suggestions, okay. So you will have your own notes and you have the screenshots. You put your work on your notes and just write everything that can be written, okay. And then after finish, you can look up the screenshot, and then you can look up your notes, and you can think, do you understand what you write from the screenshot or from the notes? And then you can sum up and then maybe revise your notes, okay. And that is like, you have like iterations, like when you do research, you read some references, okay, you put some notes on the references, and you cite the sources, what is the sources and how you get there, and what you get from the source, and then you keep cycling that, okay. And that's how knowledge build, okay. That's how you study, get better, okay. If you start from something that you know, it will be very easy to move forward. But if you are keep missing out, it means that there is something wrong in your way of learning, okay? So yeah, we need to at least to make it better, okay, the study, okay. Okay, Next is this. Okay. Simplify. Very simple question, but maybe need some more understanding to solve this. Okay, anyone? So this will, I will like show you later some other property that is not yet really been given, but you can try to find how to use that or to find this property. Or you can just using the basic definition on log. But I would like to try using some special property to help you and to give you some idea how to solve some questions like this. At least there are 3 ways to solve. And each one is, I think, not very long. And you can basically choose. I just read your chat, Alvaro. We begin to factor like the basic. This is the previous question, right? Or this one? Or last one? Or this one? No. The new one, right? The new question, right? Yeah, you can express using the exponent. You can express. That is one way to solve. You can express. So remember that the very basic understanding of log from here, if we take in the log definition, log base of A, this will be C, and this will be equal to B. So basically, it says that for with power of something is equal 8. You can write this as x. Yeah, Kai, log 8 over log 4. Yeah, you can start from there. It's actually another way to solve. It's also okay if you start from there, log 8, log 4, but you need to, you can simplify log 8 over log 4, right? So if we try to solve from the exponent, let me start from the exponent. We can basically, 4 is 2 by 2, right? 2x, and this will be 2, 3. So x is, or we can write here, right? 3 over 2, okay? And the same thing with the 27, right? 27 means 27 equal 3, and which x, right? You can write maybe y. So here we have 3 with power of 3, y, right? And then 3, and this is just 1. So y is 1 over 3. So 3 over 2 minus 1 over 3 is, we can multiply by 3, with 9 over 6 minus 2 over 6, which is there. Okay, that's the first one. The alternative one, we can check, at least we have 2 alternatives. So first is, we can use the change of base. So here we can have log 8 over log 4, and this will be minus log 3 over log 27. Remember, when we're using this method, we are using the change of base. We can add any base we want, practically any base we want, okay? So to give you some idea, we have 8 and 4 on the first one. So I think it's best to get the base as the number that is related to 8 and 4. And 8 and 4 is starting from 2, right? 2 with power of 2 is 4, 2 with power of 3 is 8. So we can write 2. The same way, for the right part, we can add 3 and 3, because both 3 and 27, they have the common number that is expressed from 3, right? We can have 3 with power of 1, 3 with power of 3, okay? And then we can write the equations, and this become log 2 for power of 3. This will be log 2 power of 2, and log, and this is just 1, okay, just 1. This will be log 3 power of 3. So this will be going into front, it's going into front. This will be 3 over 2, because log base of 2 is 1, right? And this will be minus, it's going here, 3, right? So 1 over 3, same, 7 over 6. Okay. The third method, okay, let me get smaller here. Okay. Now let me put the third one is, so let me write log 4a. Okay, we can write this, let me write this first, okay? Log, this will be 2 with power of 2, and 8 is 2 with power of 3. Okay, I will write 3 over 2. Okay, and this log, I will explain later after this. You can write log 3 with power of 3 and 3 with power of 1, and this will be 1 over 3. Okay, so if we have log A, B, okay, with power, let's say C and D, like that, we can write D over C. Or if we have log, let's say A with power of C, this is B, and this is just 1. This is just 1 over C. If you have log base of A, B with power of C, I think it's very clear for this one, right? This can be written as oh no, wait, not B. Should be A. Sorry. This would be C. Okay. Because log base of A is 1. Okay. So this will be another property that sometimes helpful for log, especially for um, simplifying the log. Okay. So 3 ways to see. You can use change of base. You can use the basic definition shifted through the exponent, or you can use the last one that is using the property for. It's actually from the change of base. It's actually the same thing from the change of base. Okay. Okay, let's say another one. Okay. So I think because we don't have much time, still have around 15 minutes. Okay. I still have 2 pages, but maybe the last one here, or if we see that we can solve another one, I think we can finish the whole questions. And now, according to what we have from the previous simplification, try to solve this equation. It is quite advanced and difficult, I think, compared with the previous questions. Okay. So what should we do first? I think we can do this first. We can change of base. Let me just write this and think which base that we can try to fix it. This will be log x log 4. Okay, I think can add base 2 to be safe, because 2, 4, and 16 can be simplified using 2, right? So this will be log base of 2x plus 4 log of 2x, and this will be 2, right? Because of the 2 from the front, like that. And this basically log base 2 of x, and this will be 4, and this will be equal 1, equal 1. Let me make it smaller. And then what we have now is 16 log 2x plus 2 log 2x, right? And then plus 2 log 2x. So 16 plus 2 plus 2 is 20. Oh, wait, it's not 2. Not 2. That is half. Half. Okay. So 18 plus 1 over 2. So that will be 37 over 2. Right? And this will be log base of 2x and 37. So we can cancel this. Right? And then log 2x equal 2. Because we need to make sure that the x is only positive. Then this will be x will be 4. Okay, interesting, right? So I bet you try to move this here, right? And it will be crazy. So it doesn't always like that, so we can use different way to solve it. Okay? Okay. Do you want one more question, or we finish up until here? Guys? Do you want to continue a little bit more? Or just one more question? Another way, I think, so far I couldn't find another way. Or another way, but I think the other way that can be as an alternative, basically similar, but maybe different writings. Like for example here, I can start taking, for example, I'm taking the log 2x as y. Okay, so it will be 16y plus this one, log 4x, it's become, so log 4x is equal to log 2 by 2x. So 2 will be half log 2x, okay? Or this will be 4 multiplied by over 2y, okay? And then another one, the log 16x, this will be equal to 1 over 4 of log base 2x. So we have plus 2 over 4y equal to 37. Basically the same. Okay, basically the same, but I'm trying to write with another alternative that can maybe it can help you to understand a little bit. Let's start from here, taking this as one variable. Okay, so another alternative to approach. Okay. I think sometimes this way, too much words or numbers in one equation. So I think if you use some substitutions, maybe it will simplify. Okay, maybe it will help. Okay. Okay, maybe one more question. Okay, one more question, and then we can done. We will done. We'll finish. Okay. 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 This one. The largest domain means that the possibility. Okay. I mean, it's basically the domain itself. The largest domain means that we need to think what is the possible domain of this equation. So based on the domain, later we are going to see some solutions. And then we need to check, right? We need to check the solution. And how to check the solution is basically check the domain. Check the domain. I hope you get my idea, okay? Why domain is important here. And the question is also solve the equation for over the largest real domain, which means that we need to make sure that it is within the domain. I think should be clear or not, or maybe really no energy left. Okay, anyone would like to try before you get to sleep? Okay, I think I will start by looking at the domain first. Okay. So domain here is, oh, maybe let me make spaces here. Okay. So domain is from there, or maybe taking that this inside the log, right, should be positive. So the x squared should be greater than 1/2. And the 2 minus x is 1, 2. We are going to take it into positive 2. Okay. So this will be that or that. And this will simply, we have a -1 and positive. And we could try something in the middle, which is negative, and this will be positive, right? So we want this one. Right? We want the positive one. So either this will be less than that, and this will be. But this is not this is not the solution. This is the restriction on the solution. Okay. And let me put this a little bit small here, and this also getting small here. Okay. Now let's work on the solution. So the solution based on the definition of log, we're going to have 2 minus x squared equal to x squared minus 1. And this will be x squared minus 4x plus 4. So we have x squared plus 4x minus 5 equals 0. And then x minus 5 or plus, and x minus 1, right? So x is -5, x is 1. And oh, I forgot. Can x be equal 1? I don't think x can be 1 here. So based on this one, x cannot be 1 also. Because when x equal 1, it will be log base of 1. Base of 1 is not defined in log, right? We cannot use the base equal 1. So x shouldn't be equal 1. Okay. So this should be not included. So the only way that it's solve the equation is x equal -5. And it's true from our conclusion that it's going to be here, right? The solutions. Okay, that's it for today. Thank you for coming. Although this is not really come to the class, but the online class. I will give you the the feedback for today's class. Let me add. Yeah, do you have a question? Yes? Any question? Okay, let me put the link, the Google form. Okay. Okay, please look on your chat box. Click the Google form and just complete the Google form, and class is finished. Okay.